All right, so please put your name in the chat so that I can have that for attendance purposes. Today, we are going to
Someone's at your front door.
the carbon cycle, learn about the water cycle, compare and contrast the two a little bit. And then I will set you guys up for a climate story activity. So we're going to explore that and how that works. So hope you guys are ready. We're gonna watch some videos today. We're gonna do some talking and some sharing, and it's gonna be a really interesting class today, I think, as we think about how people become affected by climate change um, just because they don't have a choice, right? And things are changing around them and they just happen to get caught up in it. So if we're looking today at our PowerPoint slide and what we have um, for today's lesson is what we're going to go over. One of the questions that I wanted you guys to think about before we got started was, is there a way that you or your family has been impacted by climate change? And so I can definitely start, and I will start with my own story. Maybe this might have you guys think and ponder a little bit about what that means for you and what climate change means for you. But you know, when I was in high school, my family moved from the Virgin Islands in the Caribbean to Florida, to Central Florida. So Central Florida, it's in the Central Florida because it's the middle of the state, right? And I also was not on the coast, right? I was not on the coast of Florida. I was in the middle of Florida. So no beaches were nearby. I had to drive like 2 hours to get to a beach, which is surprising. People think of Florida, they think beach, but I was nowhere near a beach, which is also very disappointing for me who grew up on an island. I was like, I was used to beaches. I was like, this is not what I signed up for. So we're in Central Florida and I am entering, and I am at home visiting for the summer because I'm in college. And it just happened to be that that summer was the first summer in 100 years that Central Florida would be hit by a hurricane. So everybody thinks Florida, everybody thinks hurricanes, and they're normal in Florida, but in Central Florida, so if you don't live on the coast, you do not get hit by hurricanes very often. This happened to be that that summer, it was the first summer that we got hit by a hurricane in 100 years. So I was lucky enough to get to experience that. But I would experience it 5 times that summer. That summer alone, after 100 years of not being hit by a hurricane, Central Florida experienced 5 hurricanes. And that greatly affected my family because our house just could not handle all the water that comes with 5 separate hurricanes. And so our roof started to leak and our windows started to leak and it started to affect our house greatly. And so there were many, many years later of repairs that had to happen as a result of one summer with 5 hurricanes. And so in the vice presidential debate on Wednesday night, there was a lot of talk about how there aren't any more hurricanes now than there were 100 years ago. And I personally can officially attest that yes, there are more hurricanes now than there were 100 years ago. And they're different and they're stronger and there are different things that are happening. So that's personally how my life was affected by climate change. And you know, it's possible that a lot of you also have stories that in which your life is also affected by climate change. If you might not realize it, but different things have happened to affect the climate, even here in DC, and people's access to food and different things. But if anybody has another story to share about how they may have been impacted by climate change, it'd be great to hear it. Does anybody have a story right now? Ready? No? 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 Nobody has a story about how they were affected by climate change? Really?
I haven't experienced any apart no one that has
No?
really
No
affected.
climate change stories? Really? No flooding, no change in temperatures, no your family has had to move because of different kinds of weather that you've experienced.
I
All
done
right,
had flooding in my home from the
yeah,
storms.
okay. Right, so you've experienced flooding. Was the flooding normal or was the flooding expected, right? That's the difference, right? If it's expected flooding, then it's not climate change, but if it's, you know, unexpected flooding, then that would be an example of climate change, right?
It was unexpected.
Yeah. So that's an example of how you could be affected by climate change, right? That's unexpected flooding is definitely an example of climate change. You know, water is supposed to stay where water is supposed to stay, right? Water is, you know, rivers have been around forever, right?
We just had a massive flood not too long ago in DC.
Right. DC is a city for example, that is flooding way more than it ever has in the past. Um, and that's a result of climate change that has been brought on by the fact that more people are moving to DC, right? So the city is sinking because of infrastructure, but also because as there are more storms, the rivers that surround DC, because we have two rivers that surround DC, those rivers are becoming fuller and they're escaping their banks, right? Um, all right, so what we're gonna think about today, we're gonna take a look at the carbon cycle and the water cycle. Last week, you guys, your assignment was to review that carbon cycle video. We're actually gonna watch it together just because I wanna recap a couple of things. We're gonna watch the carbon cycle video and then we're also gonna discuss the water cycle. So we're gonna start there. And I'm going to go into Schoology. You don't have to go into Schoology right now, but you will have to go into Schoology in a second. But let me go into Schoology and share this video with you all first. So I'm going to go into week 4 so you can see the carbon cycle. We're going to be working out of week 5 today. I'm just going to show you this video though. Click on the wrong thing. One.
Carbon dioxide, or CO2, is the main greenhouse gas in climate change. So how does CO2 get into our atmosphere? Well, carbon is part of a cycle. It starts with the sun, which hits the Earth's surface with more energy in 1 hour than the whole world uses in a year. Plants, which are kind of like biological chefs, take that sunlight and then suck in some CO2 from the air, mix them together, and bam! They create a stored form of energy in the form of carbohydrates, such as glucose and sucrose. The process is called photosynthesis. When animals like us eat those plants, our stomachs convert that food back into energy for our own growth. Greenhouse gases are a byproduct of this process and are released through waste. If those plants die, they decompose, and tiny microorganisms break down those carbohydrates and again release greenhouse gases as a byproduct. As you see, energy originates from the sun and is then transferred as it moves through the food chain. But sometimes, carbon-based organisms, like plants or animals, get stuck in the earth. When this happens, they're compressed under tons of pressure and turned into carbon-based fossil fuels like oil, coal, or natural gas. Since the Industrial Revolution, humans have been pulling those fossil fuels out of the ground and burning them, activating the stored energy to make electricity and power engines. But the thing is, it also releases millions of years worth of stored CO2 back into the air. In addition, humans breathe in oxygen and breathe out CO2, but plants do the opposite. Trees suck up huge amounts of CO2, which balances the cycle. Thus, deforestation reduces the plants that store CO2. We're attacking the cycle from both sides. Think of it like a computer. A computer can operate a few programs at a time, right? Normally, when you've finished with the document, you save and you close it, so as not to overwork the computer. Then imagine you stopped closing your documents, so they were all open at once. Your computer wouldn't be able to process it all. It would start to slow down, and then to freeze, and eventually it would crash, which might be where our environment is heading if we keep overloading the carbon cycle. So, is there any way to rebalance the ecosystem? What about technology? Technology is defined as a technique to solve a problem. And so, sustainable technologies are those whose output is equal to their input. They do not create negative externalities, such as CO2, in the present or the future. They sort of cancel themselves out to solve the problem. To achieve this, we need to invent sustainable technologies. If we put all the ideas and technologies ever created into one circle, then invention is the pushing of the boundaries of that circle. And the area outside of the circle is infinite, meaning the potential for invention is limitless. Think about some of the incredible clean technologies we have today. All those ideas have one thing in common. They all came from people. People innovate. People create. It's the limitless potential of creative people to build unimagined technologies that is going to stop climate change and rebalance the ecosystem. And that is something to be hopeful about.
All right, so that is the carbon cycle. And with that, I asked you guys a couple questions and a lot of you answered them. But we're gonna go over them because there's a lot of misconceptions even after watching the videos about what these answers are. The process of plants turning light and carbon dioxide into sucrose and glucose is called what? Is it carbohydrates, decomposition, deforestation, photosynthesis, or synthetic biology?
D.
Photosynthesis.
Yes, photosynthesis, right?
Yeah.
The one is definitely photosynthesis, right? That's the process where your plants and trees are using carbon dioxide, turning it into their own energy. And one of the byproducts of that, what they give off as a result is oxygen, which is what we need to breathe in, okay? What about greenhouse gases? Greenhouse gases are caused by what?
All the above.
All of the above. All of those things cause greenhouse gases, okay? Yeah, they all cause greenhouse gases: cutting down trees, burning fossil fuels, decomposing organic matter, and waste created throughout the food chain. All right, so all of this is what affects the amount of carbon in the atmosphere, right? So we have carbon naturally in the world, but CO2 coming into the atmosphere is a result of all of these things happening, all right? How does burning fossil fuels create energy? This one was a tough one. A lot of people got this one wrong because there's a lot of options here. It says of electromagnetism, the stored energy in the carbon-based fuel is converted from sunlight fuel for the
I'm gonna say D.
oil has superpowers, the potential energy the pressure of the physical hospital is being released of gravity. Yes, the answer is D. The potential energy of all the pressure put into the fossil fuels is being released, okay? So this is why burning fossil fuels creates energy, is because of D. There is potential energy, and to release it, you have to burn the fossil fuels. Energy in this world is not created. We do not create energy. We just convert energy from one type to another type. Okay, we don't create energy. This world has all the energy it needs, so we just harness it and put it into different things, right? When we turn solar energy into electricity, we're converting energy, okay? So we are always converting energy. We don't create energy, okay? All right, why is technology a solution to climate change?
I said D.
All right. It is definitely
I
not.
said
I mean
D
E.
too.
I mean E. I'm tripping.
I said D.
Yeah, E.
Okay, so all of the above is not true because there's a couple of things that are opposite here, right? So it is unfair to require some nations to stay poor so that we may reduce CO2. People want a catastrophe or shorter lifespans to reduce population. That's not a reason. That has nothing to do, neither one of those
No.
technology.
I,
Right? So
I'll go with C.
yeah, so the answer is actually D. So there's unlimited potential to invent sustainable tech, right? Because people are always inventing things, there has to be a way, we have to be able to research a way that can help reduce our dependence, right, that we currently have on fossil fuels and on creating more harm to the world. All right, and then number 5, humans breathe in blank and exhale blank. Breathe in and exhale what? What do they breathe
Breathe
in?
in oxygen and exhale CO2.
Carbon dioxide. Perfect, right? That's it. That was the That was supposed to be the easy one. Numbers 1 and 5 are supposed to be the easy ones. And then you're supposed to do a little bit more thinking with 2, 3, and 4. I just wanted to clarify that. I also wanted to bring back up this image so that we can talk about the carbon cycle really quickly. So if we're looking at the carbon cycle as it is here, right? This is our carbon cycle, and essentially what's happening is the carbon cycle is an example of a chemical cycle, right? Meaning that this chemical is here and present because of the things that we do, right? But it also is naturally occurring, but we affect it more because of what we see on the right. The auto and factory emissions causes more CO2 to be in the air, right? And as we cut down more trees to make more space for people and things and roads and whatever other reasons that we want to cut trees down, with less trees to absorb the CO2 and take it in, we leave more carbon dioxide in the air, right? Which is what is causing the earth to be warmer. We need CO2. We need CO2 because it helps to keep the earth warm in general, but too much CO2 is causing the earth to be too warm, okay? So carbon exists in us, in our bodies. When we die, we return carbon to the earth. When animals die, they return carbon to the earth. The carbon settles in the earth. It's in the earth. It's part of the earth, right? We can get it out of the earth by using those fossil fuels, right? We use, an example of fossil fuels would be petroleum or oil, right? And we also use coal. Coal is a fossil fuel from the earth, right? So all of these things are produced by the carbon that we leave inside of the earth, okay? All right, that's the carbon cycle. So what I need you guys all to do, I need everybody now to go to Schoology. I want you guys to go to the week 5 folder in Schoology, and I want you guys to answer the question that is there under week 5. It should be one of the first items that are there. We're going to talk about the water cycle, okay? So I'll show you on my screen just so you can see it. But you want to be in the week 5 folder, right? So you got courses, science 3 for Mr. Graciano, of course. And you want to go to the week 5 folder that says climate stories and the water cycle with today's date on it. Today is October 9. And I want you guys to look at that first thing that's listed there. It says, what is the water cycle? Okay, so what is the water cycle? You know what? Never mind. Don't do it on your own. We're going to watch it together. Let's just watch the video together. Why
not? It has no taste, color, or smell, and we often look right through it. It covers over 70% of the Earth, cycling from the oceans and rivers to the clouds and back again. It even makes up about 60% of our bodies. With all this water around and inside us, it's easy to take its presence for granted. But in the rest of the solar system, liquid water is almost impossible to find. So how did our planet end up with so much of this substance, and where did it come from? As you probably know, a water molecule consists of 2 basic parts. Hydrogen, the simplest of all elements, has been around since close to the beginning of our universe. Oxygen entered the scene several hundred million years later, after stars began to form. The massive pressure at the center of these fiery infernos was so great that hydrogen atoms fused together to form helium. Helium, in turn, fused to form heavier elements like beryllium, carbon, and oxygen in a process known as nucleosynthesis. When stars eventually collapsed and exploded into supernovas, these new elements were spread across the universe and combined into new compounds, like the now familiar H2O. These water molecules were present in the dusty cloud that formed our solar system, and more collided with our planet after its formation. But there's a big question that we don't have the answer to. How much water arrived on Earth? And when? If, as one theory goes, relatively small amounts of water were present on Earth when the rock formed, The high temperatures and lack of any surrounding atmosphere would have caused it to evaporate back into space. Water would have been unable to remain on the planet until hundreds of millions of years later, when our first atmosphere formed through a process called outgassing. This occurred when molten rock in the Earth's core released volcanic gases to the surface, creating a layer that could then trap escaping water. So how then did water get back to the planet? Scientists have long suspected that much of it was brought by ice-bearing comets, or more likely, asteroids that bombarded the Earth over millions of years. Recent research has challenged this theory. In examining carbonaceous chondrite meteorites that formed shortly after the birth of our solar system, scientists have found that not only did they contain water, but their mineral chemical composition matched rocks on Earth and samples from an asteroid that formed at the same time as our planet. This suggests that the Earth may have accumulated a substantial amount of water early on that was able to stay put despite the lack of an atmosphere, though asteroids may have brought more over the eons. If this turns out to be true, life may have formed much earlier than previously thought. So we do not yet definitively know whether the water on Earth came from its initial formation, later impacts, or some combination of the two. Regardless, the water that runs from our showers, drinking fountains, and faucets is something that didn't just come from a nearby lake or river, but first underwent a cosmic and chaotic journey to get here.
Who knew? Who knew all of those exciting things about water? That where water came from? Who even knew, right? So water, which is something that we desperately need, right? We need water to survive. Our planet is mostly water. Our bodies are mostly water, right? This story about water is something that we definitely don't know and don't realize, right? But water is super important, and it's also one of the very important cycles that we depend on. So according to that video, what do we think the answers are to these questions? What is the oldest and most abundant of the elements? They said it right at the beginning. What is the oldest and most abundant of the elements? Do we know?
Hydrogen.
Hydrogen, okay. Anybody agree?
Mr. Garsonia, I wasn't really understanding anything.
Okay, that's fine. We can always watch it again. So what about number 2? So we're gonna go over the questions first before we watch it again. So I wanna see so now we know what
Evidence does not support the theory.
Yeah, which evidence does not support the theory that water came much earlier in Earth's history than one suspected? I should say came. Let me edit it, the post right now. It should say the word came, not. It came much earlier. Okay. Which evidence supports the theory that water came much earlier in Earth's history than one suspected? Examination of fossil remains, carbonaceous chondrites. Yeah, good, Toya. Examination of rocks in Earth, examination of asteroids, right? So yes, we definitely mentioned the examination of carbonaceous chondrites, as Toya suggested. That was what supported that theory. What is the most likely scenario of how water was initially delivered to Earth? Meteors, ice-bearing comets, outgassing.
Ice-bearing comets.
Ice-bearing comets, that's what was mentioned. And which 2 reasons were thought to have rid Earth of its early water? Lack of an atmosphere, collisions with space debris, lack of gravity, or high surface temperatures?
Was it in a lack of gravity?
Lack of gravity? There's definitely lack of something, right? So I do want us to, because I want us to get a good understanding of where water comes from, because it's important to understand where it comes from, because then we can know why it's so precious to us, okay? So we're gonna watch it again. So yes, you guys are on the right track. I heard some really great answers for 2 and 3, and for number 1. For Miriam, you were definitely right on number 1. But number 4, we seem to miss a little bit. So let me play it again. It's just 4 minutes. We can do 4 minutes of a video, guys. I promise you. As long as Mr. G knows how to spell, and Mr. Correct his spelling. Okay, so we're gonna watch it one more time.
It has no taste, color, or smell, and we often look right through it. It covers over 70% of the Earth, cycling from the oceans and rivers to the clouds and back again. It even makes up about 60% of our bodies. With all this water around and inside us, it's easy to take its presence for granted. But in the rest of the solar system, liquid water is almost impossible to find. So how did our planet end up with so much of this substance, and where did it come from? As you probably know, a water molecule consists of 2 basic parts. Hydrogen, the simplest of all elements, has been around since close to the beginning of our universe. Oxygen entered the scene several hundred million years later, after stars began to form. The massive pressure at the center of these fiery infernos was so great that hydrogen atoms fused together to form helium. Helium, in turn, fused to form heavier elements like beryllium, carbon, and oxygen in a process known as nucleosynthesis. When stars eventually collapsed and exploded into supernovas, these new elements were spread across the universe and combined into new compounds, like the now familiar H2O. These water molecules were present in the dusty cloud that formed our solar system, and more collided with our planet after its formation. But there's a big question that we don't have the answer to. How much water arrived on Earth? And when? If, as one theory goes, relatively small amounts of water were present on Earth when the rock formed, the high temperatures and lack of any surrounding atmosphere would have caused it to evaporate back into space. Water would have been unable to remain on the planet until hundreds of millions of years later, when our first atmosphere formed through a process called outgassing. This occurred when molten rock in the Earth's core released volcanic gases to the surface, creating a layer that could then trap escaping water. So how then did water get back to the planet? Scientists have long suspected that much of it was brought by ice-bearing comets, or more likely, asteroids that bombarded the Earth over millions of years. Recent research has challenged this theory. In examining carbonaceous chondrite meteorites that formed shortly after the birth of our solar system, scientists have found that not only did they contain water, but their mineral chemical composition matched rocks on Earth and samples from an asteroid that formed at the same time as our planet. This suggests that the Earth may have accumulated a substantial amount of water early on that was able to stay put despite the lack of an atmosphere, though asteroids may have brought more over the eons. If this turns out to be true, life may have formed much earlier than previously thought. So we do not yet definitively know whether the water on Earth came from its initial formation, later impacts, or some combination of the two. Regardless, the water that runs from our showers, drinking fountains, and faucets is something that didn't just come from a nearby lake or river, but first underwent a cosmic and chaotic journey to get here.
All right. So, sorry, let me turn the camera on. Just to recap, we definitely have the oldest and most abundant of the elements as hydrogen, right?
Mm-hmm.
The evidence, I'm sorry?
Number 2, what was it again, on the rock? Or it's B?
It's B, examination of carbonaceous chondrites. Yeah. And then number 3, what is not unlikely scenario of how water was initially delivered to Earth?
Iceberg.
Okay, so what is
Not, that is the problem. We didn't see the what is not.
Yeah.
I think we're more looking at how it came, but when you say what's not, so different, it turns the question differently.
Yeah. So the only thing that wasn't mentioned is D, right?
Asteroid, right?
Oh yeah.
Okay, and then which 2 reasons were thought to have rid Earth of its early water?
A.
And what else?
And surface temperatures.
Very good. A and D. Okay, lack of an atmosphere and high surface temperatures, right? That means all the water evaporated because it was so hot, and the water wasn't kept in because there's no atmosphere, okay? So why is that important now? That's important now because now that we have an atmosphere, we don't get water from anywhere else. All the water that we have on Earth, right, is all the water we are ever going to have,
Believe.
okay? So our water goes through what is known as a cycle, right? Our water is a natural cycle. Unlike the carbon cycle, it is a natural cycle, right? That means that man can't really affect it as much as we think we can, right? But, you know, from rain to the oceans to our groundwater, all of it is all connected, okay? And we need all of it to survive, but we can't just create new water. Water has to already be here for us to reuse it in different ways, okay? So I'm going to go back into our folder here and just open up the diagram of the water cycle so that we can see what we're working with. Okay, so this is the water cycle. It is not labeled, but the words are under here, under it, and we're going to talk about where those words might go. Okay, but this is just a general example in black and white of kind of what that water cycle looks like. So with this water cycle, we have what's happening. Describe to me what you guys think or what you see as things that might be happening in this example that you see.
It's showing like it's raining from the clouds.
Okay, good. So what do we call that? What's like the scientific word for something like that? What do we call rain or anything, any kind of liquid that's falling from the sky?
Precipitation.
Very good. I don't know who that was, but that was great. They were like ready too. They were waiting for it. They're like, listen, this is my answer. Okay. So what's happening here is definitely known as precipitation, right? That is water or snow, anything that's coming from the sky. This is definitely precipitation. Very good. I love that. Precipitation. Okay. And precipitation is one of the first steps. Well, it doesn't matter if it's not the first or last or anything, because it's a cycle, right? That means it's going to go back and forth. But it's definitely one of the most important steps in this cycle, the idea of water coming from our clouds, okay, in the form of precipitation. Great. Is there anything else that we see? Anything else that we're noticing that's happening?
It's also going back,
coming down.
going up also.
Okay. Yeah. So what do we call that when we have water like in a pot, for instance, and we're boiling it and we have steam coming off of that? What is that called?
Evaporation.
Evaporation. All right. Very good. Okay. So we have evaporation happening as well. So when our water leaves something like the ocean and goes up into the clouds, right? That is known as evaporation. Okay. All right, so that's what's actually happening right over here. This is evaporation. This is an example over here of evaporation. Okay. And what is this step, I guess, in between evaporation and precipitation? When, you know, you put something in the fridge and it becomes cold, so all that water appears on the outside of it. What is that called?
Condensed.
Okay, good. Condensation.
Condensation.
Okay, great. All right. Anything else that we see that's happening? We can also just describe it if we don't know the scientific words, but what else do we see happening with some of this water?
There's something about trees, but I don't know what the tree happening with the trees though.
Oxygen.
Oxygen, what do you mean? Say more. Explain yourself.
Reproduce, Mr. Chi.
What do you mean? What's reproducing?
The whole evaporation, condensation.
Okay.
Oxygen from the
Some
trees,
reproduction.
sucking up the water.
Some reproduction has to be there.
What do you
Something
mean?
like there's
What do you mean reproduction?
accumulation.
What does reproduction have to do with the water cycle? And how does water affect that? And I'm
It's
saying you're wrong.
like if it's not, if it's, you don't have enough water, then it will be unable to reproduce some stuff.
Okay. All
Because
right.
water is like more like it's, as they say, water is life.
Okay. Water is definitely life. Okay. All right. All right. I'm gonna think about where you guys are coming from, right? And I'm just gonna,
Steam flow.
okay, good. All right. Right. So we have this water that's here, right, is flowing down, right?
Mhm.
So we have precipitation, right? But precipitation only hits certain parts necessarily,
Accumulation.
right, of our of
Exactly.
where we're of our earth, right? But the water
Runoff.
is stored somewhere, right? So we have what is called runoff, right?
Runoff. Yeah.
So there's some runoff that's happening, right? So we have what is known as surface.
Surface runoff.
Okay, yeah, and that's what's happening right up
And
here.
then infiltration.
Good. We have surface runoff here, and I heard somebody mention the word, surface runoff.
Infiltration. Infiltration.
Yes, filtration we're going to get to. We also have accumulation here, right? What we have in the ocean is accumulation. So we have a large body of water, an ocean, a lake, even a river, right? That's accumulation. It's a collection
Of water.
right? Okay, good. If we scroll down, we'll see some of the other terms that we may have missed, right? Okay. So transpiration is what they're describing here, right? What is happening from the trees back up into the atmosphere.
Transfer into the atmosphere.
All right, so that's like, and that also happens with us, right? We also have a process of transpiration. Does anybody know what that's called when a person has
Sweating.
transpiration? It's
Yeah, when
sweating.
someone's sweating, yeah.
Right, when we sweat,
Perspire.
right?
Perspirizing. Whatever it is.
Yep, perspiration, right? Yep.
Yeah, perspiration.
Fire.
Transpire by
Fire, yep. So sweating, perspiration, transpiration is the tree version of that, right? When the tree takes up too much water and that needs to just release it back out, they release it through their leaves, right? And it goes back out. Sometimes they also release it through the roots if it's able to, but if the ground is too saturated with water, it can't do that, right? And then that's when the roots drown, right? And you can overwater your plant, that's when that happens. Okay, so then we have next, from the trees, we also have what's known as the subsurface runoff, right? So when it leaves the ground, right, and goes into a body of water, that is subsurface runoff. Okay, all right, and then we're missing one more step. I think it's down here as well. Nope, okay, yeah, we have it all. We have all of them listed. We just have another example on the left here of more condensation.
Condensation.
Yeah, so this is another example of condensation, right? Because anything that transpires or evaporates has to condense to make clouds, right? So clouds are just an example of our condensation, right? And when it condenses enough, when there's enough condensation, then we get precipitation, right? And then the cycle starts over again. If you want to think of precipitation as a start, you don't have to, right? Because there really isn't a start and end because it's a cycle, it's a circle, it just goes around, right? And so there's no like beginning and end to it. But as you can see here, our water, right? So we use it all over again. And so that's why it's so incredibly precious to us, right? We need water for life. Having clean water is important, but remember all of this water gets recycled, right? All of it. So your sewer water, where does your sewer water end up?
Back in your oceans.
Back in the oceans, back in the rivers, back in the lakes, right? And eventually that stuff evaporates, condensates, and comes back down, okay? This water is all recycled, okay? All of our water is recycled. But it also makes us aware of the fact that there are some places that don't have clean water, right? And those places that don't have clean water is a result of them not having a places where their water can be treated, right? We're very lucky in this country. We have a bunch of treatment plants, right? There are plants everywhere to treat our water. If you live next to one, you also know how terrible it smells, right? But we need those things in order to make sure that we have our clean water, because we don't have access to currently in DC, for instance, to clean water because our rivers are polluted and the ocean is too salty, right? So we need those treatment plants to give us water that we can use. But then when we don't have that, then we would be dependent on things that are not clean for our bodies. But this water cycle is going to work in conjunction with the carbon cycle to affect climate change. How does that work? Well, that works because the hotter it is, the more evaporation that we have. The more evaporation that we have, the more condensation that we have. The more condensation that we have creates bigger, stronger, and longer lasting precipitation, which turns into storms, right? So when we have this water cycle that's happening naturally, right? Nothing is going to affect the water cycle from happening. It's just going to happen. It's going to happen more if there's hotter air causing more evaporation, okay? And this is how these things are going to work together. And this is how nature is going to affect our world, right? Because with more evaporation causes more condensation, causes more precipitation and more storms, okay? So that's how these things kind of work in concert. But the things you have to remember about the carbon cycle versus the water cycle is that the carbon cycle, right, we affect directly, right? People affect the carbon cycle because of production of things, right? We have fossil fuels that we burn, we cut down trees to make more space, right? We have a great effect on the carbon cycle. We have a much lower effect, almost no effect on the water cycle because the water cycle is natural. The water cycle is just gonna happen no matter what we do. Water cycle is just gonna keep going, okay? So the chemical cycle of the carbon cycle is more affected by us. Water cycle is very natural, it's just gonna happen. No one can really stop it, right? So these are those two cycles that are working together to kind of affect how our climate changes.
Mr. G, I noticed it didn't say anything here about like springs.
So springs would be, that's something where we're thinking of accumulations of water, right? So again, that's a natural source of where water is, right? So it's an accumulation of water. So an ocean, a lake, a spring, a river, that's accumulation.
Okay.
Mr. J,
Mhm.
you talked about, you said water cycle is natural.
Yeah.
And that we human doesn't impact or affect it.
Yeah.
But the carbon cycle we impact.
We do. Yep.
So why is it that when we have rainfall, I mean, when we have storms and hurricanes, people say it's climate change?
Mhm. Yeah, well, I just explained that, right? Because so while those storms are natural, right? The reason that there's more of them is because the earth is hotter, right? Which causes more evaporation, which causes more condensation.
Okay.
To more storms.
Okay, that is because of the carbon cycle that made
because we increased the amount of carbon in the atmosphere, right? By the things that we've done, we've increased the amount of carbon. By increasing the amount of
it
carbon,
makes them more effective now because we're cutting down.
That means technically we are still impacting this natural cycle of. We're still having, what we're doing is still affecting the water cycle as well.
Yeah, in a sense, for me, it's just like the water cycle is happening regardless. With what I'm trying to say, like the water cycle just happen, right? But we have a greater impact on the carbon cycle because we have a greater impact on
what we produce.
Right.
Yeah. Okay. We can. Okay. You are talking about like we can help reduce the carbon cycle.
Right.
Okay.
Yeah.
Like here, like for instance, for us in Jamaica, we the residents, the citizens, we are allowed to burn garbage at home, while here it's not permitted.
Mhm. Yeah. And there are other places too, especially like this might be a change that may happen in large cities here in the United States as well. But in Latin America, so in countries south of the United States, Mexico, Chile, Colombia, in major cities in those countries, depending on the last digit of your license plate number, you are not allowed to drive your car on certain days, right? And that reduces the amount of pollution in the air.
Mhm.
And so that's just the way that they've decided. Like, we're not going to restrict people from having cars. We're not going to be like, oh, you can't own a car, this, that, whatever. But they're just like, you can't drive your car on this day,
Yes.
right?
They were doing
That's
shopping
because
like that in
Yeah.
I don't remember the country right now, but during this Corona, Cayman, they would do shopping like that in Cayman. You'd
Yeah.
have to go out on certain days according to your name.
Yeah.
First.
Yeah. And
Of
that
your-
just helps to reduce, the amount of people who are moving around.
moving with a car.
Yeah.
I think even in Lagos, when Lagos was the capital of capital city in
Yeah.
Nigeria, they used to have days where car will go out. Not
Yeah.
every car was going out because there was a lot of pollution and at the same time traffic. So they were trying to reduce it.
Mhm. Yeah. Yeah. So just like, little changes like that can actually have a big and lasting impact, right? Not only in, your daily life. Yes, your day might be affected because you're like, oh, I can't use my car today. And that might be an adjustment that you have to make. But you also notice in a year's time, oh, I'm breathing better, right? There's less pollution, right? But also that less pollution will help to reduce in general the amount of heat that we're creating in the world, right? So there's small sacrifices like that that can have a big impact. But we have to get there. We have to get to those points where we're willing to make those sacrifices. Okay. Any additional questions about the carbon cycle versus the water cycle or about how they work together?
No.
No. Sorry. And I'm going to replace this example of the water cycle with one that's filled in, so you guys don't have to go back and fill it in later. I wanted you guys to have a regular document, but did not do that. Okay, so the third thing on here is a link to just a diagram. I will change that link right now. Link. Okay, let's try that out. No. Okay. Just want to change it so that it will open.
Mr. G, before you start, this part you brought, whenever you send an assignment through this medium, it is difficult for me to write on. That's why I've not been doing certain assignments because I had to go to Word and I was having problems with words. How do you write on it just like as you wrote all those things on?
Yeah, so you have to use Cami, and I'll show you how to do that when we get to an assignment. Yeah, you should be using Cami and not Word, because Word is much harder to access, so use Cami. I'll show you how to do that in a second, Jenna.
Okay.
Yeah.
Thank you.
Mm-hmm. Yeah, Miriam's the expert now on Cami.
Who?
Miriam. She's like, oh, just use Cami.
Oh, okay. I'm still having trouble. It's,
okay.
Mr. G was the one who set up my Cami, so
Right.
he's gonna do it for you too.
Yeah. I just happened to walk her through it recently. That's all. I was really just teasing Miriam, not. Okay, so yeah, so this kind of summarizes what we talked about. Some of what we talked about with the water cycle versus the carbon cycle.
Let me take a picture of this.
It'll just so this is a link that you have in the folder, Miriam. You can take a picture if you'd like to. That's no problem. But if I can just go back really quickly before you take that picture, this is the third item in your folder. So when you click this link, it'll open up to this so you can see the differences. Right? It's all laid out here for you. Okay. So the water cycle requires sunlight, right? The carbon cycle doesn't require sunlight as much because It's not going to be dependent on sunlight. There's a lot of different ways that carbon enters our atmosphere, right? But there's really only a couple ways in which we can get water into the atmosphere, right? It has to evaporate from the ground or from an accumulation of water. Let's see. But both of them are vital for Earth's climate. That's what's important. We need both of them working together, and that's how they impact the climate of the Earth. Okay. All right. So class is going to be a little short today because, well, not really. Let me not say that. Let me not overpromise because we do have a half hour, but let me not overpromise. I want to show you a couple more things, and then I'm going to walk Jennifer through how to use Cami and anybody else who needs to use Cami, but then we probably should be able to get off relatively early. The last link that's here is another interactive for you all to see how the water cycle works. Okay, and so when you play this,
When I'm not hearing you. Yeah, we can hear.
Is that better?
Yeah, okay, yeah, we weren't hearing you.
So when you guys do this, when you guys go to the site, it's going to be raining the whole time. So that's what that noise is. In the background, it's rain. But the idea here is that you're supposed to match each of the terms with the arrow, right?
Snow precipitate or fall from the sky.
All right, so then it tells you what each kind of thing is. So if you wanted to just work a little bit more with that vocabulary, that's what this interactive is for, to kind of work with that water cycle vocabulary. Okay, I'm gonna close that out because I can't hear myself because of all the rain. All right, and then so that's one way to kind of explore. You don't have to do that. That's not an assignment necessarily. I have not included as an assignment. It is just the link, right? When it's an assignment, you'll see that you have to click submit and all these other things. That's just an interactive if you need it, if you need the help with learning the vocabulary, if you want to explore more. All right, the assignment that I would like you guys to do, and you actually are not going to need Cami for this, so it's really interesting that you would ask about submitting things today. But this assignment, practice number 1 here, you have these tasks where I need you to write a couple sentences and then watch this video and reflect on the video, okay? When you do this, all you're gonna do is you can copy it, right? By highlighting it and clicking copy, okay? And then you can put it into your submission. So when you submit on the right, and I'll show you how to do that. Let me show you right now how to submit. Okay, so when I click submit assignment, that's what's going to show up on the right. Okay, I can create my assignment right here in Schoology. I don't need to go to Word. So when I click, when I paste it, I can just add my comments right in here. And also after I've watched the video, I can write my reflection right in here. You do not need to go to Word. Okay. On your other documents, you should be using Cami, but you can just submit it right in here. So go, instead of going to upload, because that's the first option is upload, go to the second option, which is create. And then you can write your response directly in there. You do not need to go outside of Schoology at all.
Okay, the issue with what I used to do is just click on where I can write, and when I submit, they said no, you can't submit. Right. So I had to go back to writing on Word and then this thing. So now I've seen that I need to press create. I didn't know about that.
Way to create, okay. All right, and so normally when you have a PDF, just like here, you see this PDF here, there should be a button next to it that says open with Kami.
Yeah.
And when you open it with Kami, after you fill out the PDF or add whatever you'd like to do, it's gonna take a while to load. I'm gonna let it load, okay? You let it load, you fill it out using the text box, and I click on text box and I click inside the text box, and I can write my answer
Mm-hmm.
here, or I can use my drawing tool if I need to.
That is horrible.
Right, if you want to, you can say, oh, here's my answer, I wrote it using the tool, whatever, okay? And then you just go to the upper right-hand corner here. You might not be able to see it depending on where your pictures are on.
Yeah.
But on the upper right-hand corner, there's going to be a little button that says turn in.
Mm-hmm.
And I'm going to turn in my assignment. And that's how I turn it into Schoology, okay? And so now it is turned in. Well, it's turning in still. I have to wait. It's going to load. And then I click submit. And I've turned in my assignment.
Okay.
Okay?
But okay, but there was this I don't know, I don't know how to explain to you, but you know, you remember when you wanted to explain this circle for us, you went into a link and I brought some things which you were writing the things that you were labeling the things. It's that very that very work is difficult for me to write on, because if you open it, you can't write on it.
Yeah, so this.
But you were writing on it, yes.
So in this example here, so the one that I showed you with the water cycle,
Yes.
I just happened to upload the incorrect diagram because I wanted you guys to have the diagram that was already filled in, so you don't have to write on it. Anytime you have to write on anything, it'll be an assignment where you can open it with Kami, and then you can write on it. Okay.
Okay.
Anything that you're supposed to write on will be editable so that you can write on it.
Okay.
Okay. Yeah, I'm never going to give you something to write on that so like it will never be uploaded like this. When it's uploaded like this, as just
something like that.
About the word that says open with Kami, you will not. You're not supposed to write on it. So this one, I just uploaded the wrong one. I wanted you to have the one that was already completed. So I just have to replace this one. But okay, that's it. But
okay, thank you.
As far as your assignments for today, right? What I need you guys to do, because you already watched it, the video. If you could just go in and post your answers, a couple of you already did. Just paste the answers for numbers 1 to 4 in here, right?
Remember
and what I would also like you guys to do, and you can do this at any time over the next week. This does not have to be done today, right? The response to the discussion question needs to be done today. But what you can do anytime over the next week, because you have plenty of time. Remember, there's no classes next week. I want you to do practice number 1 for the climate story. So you're going to answer those questions, watch this video and respond to the video. It's a very informative video. So just take the time to do it whenever you have time to do it. You have a full week because we do not have classes next week. So you have time to do this. So take your time and do practice number 1 as well. And then when we come back in 2 weeks from today, so that would be the 23rd, okay? Yes, 23rd. When we come back on the 23rd, we will, do a quick little recap of what we've learned so far in science. We make sure we re-mention the scientific method. We talk about how to make science work in general, and then we're going to move on to our next item, which is going to be discussing energy. Okay. We talked about energy a little bit today because both the water cycle and the carbon cycle have a little bit of dependence on solar energy, the sun. So we are going to talk about energy when we come back to classes.
Okay.
All right. So like I promised, and I didn't want to overpromise, but because you guys do have kind of a longer video to watch later on your own, I did want to end the class early enough so that you have enough time to do that on your own. So I'm going to end early, but I hope to see you all on the 23rd again. If I have you only for science, and if I have you for math, I will see you on the 19th. Make sure you all use this time wisely. Don't do anything too crazy. COVID is still a thing, and the numbers in DC are increasing. They are going
So,
okay? That was the report that came out last week, Friday, that our numbers are going up. We also know that the numbers are going up because of our president who lives in DC. He's to those numbers going
Did you know, I actually go to the store and I was in the vehicle and watched a lady took up a mask from outside on the ground, put it on and went into the store,
Stop,
came back out and take it off and throw it back on the ground.
stop it.
My husband and I was like, oh my God, this is the craziest I've seen.
I can't deal with that. That's ridiculous, Miriam. That is
Mr. Honestly, the only thing I saw, I didn't get the chance to tape it because it was like, did she really do that?
oh, that's amazing.
Because they wouldn't let her in the store. If she had gone to the store door without the mask, they would not have let her in.
So she went and grabbed the mask. That's
And that's
Dirty mask from
risky.
the ground.
That's risky.
That's craziness. All right, y'all.
Mr. G, which one you say we have to do first? Because I don't want to get confused.
Yeah, absolutely. So what I want you guys to do first, so before you even think about closing your computer today, just make sure you have your response in from the video that we watched earlier, the water cycle.
So that's the one that we watched and answered.
Yeah. So yeah, just put your answers in. You know, I don't count if they're right or wrong. I just want you to put your answers in so that you can, you know, put that an example that you actually did it today. So yeah, just put your answers in for that. That's it. That's what has to be done today.
So going to chat? Do I go? No.
Yeah, just click on it and scroll down, and where it says write a comment is where you put your comments in.
So I gotta go back.
Thank you very much, and have a wonderful holiday weekend.
I have
I
And
remember
see you after the holiday.
Exactly.
question.
All right, if you guys
Do we have any other thing?
If you guys don't have any more questions, you guys can sign off. I'm here. I'm just
I
waiting
have a
for anybody for any questions, right? Yeah, so the assignment that's due today, Ijeli, is what you've already done. Okay, great, thank you. The what is the water cycle discussion, you've already done it. That's all that's done that needs to be done for today. The practice number 1, you can do that anytime over the next week, but I would like that done before we return to class on the 23rd.
Also, do I do my past assignments? I came 2 weeks ago and I'm behind over the holiday or the break. Do I do those past assignments from when I first enrolled?
So when it comes to science, you do not need to complete those past assignments, but if your other teachers are asking you to complete your past assignments in other classes, please do those first. It'll just be helpful to you to do those past assignments, but I do not have a requirement of you to do them. Okay?
Thank you. Peace and blessings.
Absolutely, no problem. All right, y'all.
All right.
Questions, feel free to sign off. I'll answer any more questions as you need. But
I'm
that's
gonna get my G off my thing now. Oh, I just remember. And then I go to Schoolology.
go to school.
All right.
Yeah, week 5. And
Yeah.
the water cycle. That's just the only assignment that needs to be done.
Oh, okay. Okay, Mr. G, thank you very much. Enjoy your week off.
Thank you.
Hope I don't have to disturb you on your week off.
It's okay if you need to. I know that you like to get caught up. So if you need to ask any questions, ask them. You know, I'll be here.
Okay.
Have a good one, Miriam.
You too, Mr. G, and the rest.